Okay, can we have a volunteer, please? Give us an opening prayer. And those coming in with funny names like Anonymous, rename your gadgets. I see Infinix Smart 5, rename your celebs. Someone uses OK. And we have our gadgets renamed such that I can call you by name. And if possible, you put the school where you're coming from. Angel, can you give us the opening prayer, please? Yes, Musa.
Good afternoon.
Yes, good afternoon.
Humble yourselves for that prayer. Oh Lord, we thank you for today. We thank you for the gift of life you've given us. We thank you for this lesson. Please help us with wisdom and understanding to go through this lesson well. Go before us in everything we do and help us understand everything. In Jesus' mighty name we pray. Amen.
Amen. Thank you, Angel. Angel, can you make your introduction before you close your microphone, your name and the school where you're coming from? And then the rest we can type amen in the chat such that we believe in that short prayer.
My name is Nasana Angel Venus Retire, and I'm coming from St. Mary's Chitende.
St. Mary's Chitende.
Yes.
Okay. Yeah, great for us, the team that side when you go back, Angel. Can we get one last person to make an introduction? Then we start our lesson. Specifically your name and the school where you're coming from. I saw Musa's hand had gone up. I don't know if you still have what to say. Musa, if you can make your introduction. Go on, please. Musa? Musa, your microphone is open. Just proceed and say something. If Musa is still getting ready. Jerry, I saw your hand go up. You want to make an introduction? Jerry, open your microphone.
Yes. Hello.
Yes, I can hear you.
My name is Anyavi Dennis. I'm a student from St. Thomas Aquinas College here.
Beg your pardon, your name is who?
My name is Jerry.
Did I hear Dennis? Is Dennis one of your name?
Yeah, Anyavi Dennis Jerry.
Dennis Jerry.
From St. Thomas Aquinas College here.
That is Nebi.
No, in West Nile District, in Moyo District.
Moyo District, West Nile.
Yeah.
Okay. Yes, you're most welcome, Jerry, and wait for us, the team that side, when you go back. Who is giving us the last introduction? At least you mention your name and where you're coming from, specifically the school where you're coming from. One last hand. Musa, I'm going to close your microphone because you can't speak. Yes, finally has gone off. Any other person? Put your hand up and I give you a chance. Okay. We don't seem to see any other hand up. I'm going to close the chat such that I open it whenever I need feedback from you. This is our last lesson. Those who were introducing from the chat, unfortunately, I didn't get to read it. But what is important is that if you put your hand up, I'll give you a chance. This is going to be a math lesson, mathematics specifically for senior 2. And make sure you prepared your questions, and I will try to answer them if there is any that I must answer. This is where we started from last week. I started by showing you topics or chapters that you will be covering when you go back to your schools. And specifically at Holistic E-Learning Platform, we give you a feel of the first topic, the one as you're going to your schools. And we chose to do topic number 5, inequalities and regions. So when you finish inequalities and regions, depending on where your school is going to start from, you go to topic 6, which is algebra 2. After that, you go to similarities and enlargement. And the last topic in term 2 will be rotation. It's what we talked about in the previous lesson. And I introduced this lesson using the pieces of chalk for those who were here. And I gave you a story of Mr. Okelo, who wanted to get some pieces of chalk after a lesson, and he sent a student to go and pick at most 3 pieces of chalk. But when the child came back, the child had carried 4 pieces of chalk. And we asked ourselves here that was 4 pieces of chalk okay? And those who were here agreed that 4 pieces of chalk was not okay, and they told us their reasons. So in today's lesson, we are specifically going to move to the number line. We are going to see how a number line works, and specifically using the number line to represent inequalities. Maybe by show of hands, if you've ever seen a number line, and you can tell me the features of a number line. If you have ever seen a number line, how it looks like, what comes to your mind when we talk about a number line? By show of hands. What do you think should not miss on a number line when you draw? Or if you've ever seen a number line, are there 2 types of number lines, or what do you know about the number? By show of hands. Anyone here who knows the number line? No one has ever seen a number line here. Okay, I'm going to pick randomly. The people seem to be failing to put their hands up. Victor, Frank, tell me something about the number line. Victor.
Good afternoon, sir.
Good afternoon.
Now, for me, what I know about the number line, I know it has the negative side where
it has what? Yes, Victor.
poor network teacher. Now what I know about the number side, the negative integers and a positive side of positive integers and a 0, which is neutral. It is not negative, it is not positive. That's what I know.
Yeah, I think that one, I agree with you, Victor. It has 3 main parts, like you said, the one that is negative, then the one that is positive, and a 0 that, according to him, a 0 is neutral. Alisa, tell me something about the number line. Is there anything you know about the number line? Carissa. That is how they pronounce your name. Or else I hear from Kakoza Isaac. Isaac Kakoza. What do you know about the number line?
That it has a positive side and a negative side.
Basically, two parts, positive and negative side.
Yes, and it also has zero at the middle as neutral.
Yeah, it has a zero in the middle somewhere, which is neutral. Okay, correct. Number line is very, very important in mathematics, and we are going to see how to work with inequalities when you're representing them on a number line. Now, giving you some one task here. I want us to see how to represent this on a number line. And in the previous lesson, we saw how these inequalities are formulated using scenarios. And today, specifically, we'll be here to see how to create a number line using those inequalities that you would have formulated like we did in the previous lesson. So if you're given such a task, how do you represent this on the number line? Any trials? Is it possible to have this represented on the number line? Any suggestions? I'm still pick randomly names here. And we name our gadgets using our names. Yes, Justin, if you're given that task, how do you go about it? Justin, if such a task is given to you, how do you put that on the number line? Yeah, no one is perfect. Any ideas you have in your mind, we can polish it to make it better. Justin? If Justin...
So that number, you can use arrows.
Which arrows? Can you try to demonstrate maybe on the screen? I've enabled the pen. Try to put and we see. If you can. Justin, which arrows are you talking about? Justin? Oh, yes. Proceed. Now you've drawn two arrows. You've drawn two arrows, actually now three arrows, but I don't know what they are. Talk, open your microphone and say what your arrows are meaning. Justin, open your microphone.
The arrow that goes to the right represents positives, and it's also used in adding. Then the arrow that goes to the left represents negatives. Yes.
Okay, yeah, that is a good one. Justin, let me hear from, yes, Anna, I see you're trying to draw something on the screen. Kindly tell us what you're coming up with. Maybe it can supplement what Justin has given us. Anna, open your microphone and try to add the voice on what you're coming up with. Anna Twizedema. That's another hard name. Anna, open your microphone and talk to us. Or if you're not ready, I want to give chance to who here? Nicole. Nicole, if you can hear me. Any ideas about how you can represent that on the number line?
I had one, but I'm not sure if it is correct.
Yes, proceed. Tell us the one you have. Okay. Why is your microphone going off?
Teacher, should I draw it on the screen?
Yeah, you can. Let me just screen for you the screen. And you draw. Yes, you can proceed. Don't mind so much about the accuracy of your line, because I know you could be using a phone and it's a bit hard. Yeah, I see your idea. It could be correct. Let me also write for you this. Okay, and write. Let me maybe help you write these numbers well. They had not come really out well. This is 2 negative. You can proceed. I'm just correcting some few numbers that didn't look well. You can proceed and proceed. Okay, yeah, I think it's a good one. Open your microphone and tell us what you've done.
The equation is x is greater than -1. So on the number line, -1 is the highest of all the negatives, but it's lower than 0. So since x is greater than, it starts from 0 onwards.
Okay. Thank you, Nicole. It's a good start. How many people agree with what she has done by show of hands? Because she has tried. Justin agrees that Nicole has done it so well. Any other person? How many people disagree with what Nicole has done? Such that we see if there are some people disagreeing. Rahim, tell us why you feel Nicole didn't get it right.
Like, the thing is supposed to be x is greater than -1. First, she has put on 0. It's supposed to be greater than -1. No, like.
So In your view, what do you think could have been done?
If greater than -1, like -1 is not among, so yeah, she's correct. She's correct. She's correct.
You're agreeing with her again? Yeah, that one is good because -1 is not among the numbers, so it becomes 0 going up. Any other person who doesn't agree with what Nicole has given us? Nicole, which school is that? First tell us your full names and the school. Nicole.
Yes?
Which school is that, Nicole?
Maryhill.
Okay. Nicole from Maryhill has told us that. I want to see if there are some people who disagree with what she has given us. No one disagrees. Okay. Any person who agrees with what she has done, of course, including Nicole herself, your hand should go up if you agree with what she has done. If you believe what this girl has done is the correct thing, x is greater than -1, and you start from 0. No one agrees with what she has done. Justin, good. Who else agrees with what she has done? Eddie. Eddie agrees. Yes. 3 people agree with what she has done. Okay, can I hear from Eddie? Why do you think she has done the right thing, Eddie? Eddie, I can't hear you.
Since they said x is greater than -1, -1 should be, no, actually, 0 should be the lowest value. So
0.
She should.
Okay. Thank you, Eddie. And I wanted to draw your attention to something funny here. Me, I don't agree with this girl. And I don't know whether I am only one or we have some other people who disagree with what she has, or I can agree with what she has written because almost everyone is agreeing. So, Justin, your hand went up and now it has gone down. I wanted to ask you some question here. You are going to write in the chat. You'll tell me yes or you'll tell me no. When they say, I've opened the chat, when they say x is greater than, when they say x is greater than -1, is 2 correct? Is 2 correct? I want to see in the chat. Don't write on the screen. Is 2 correct? If my answer is 2, is that correct? Yeah, people say yes. Good. Yes, Nicole says it's true. How about 3? Is 3 correct? Yes. Okay. I think we are together now. Okay. 3 is correct. 2 is correct. Okay. How about -1 itself? Is this correct? How about -1? Every number greater than -1 is correct. Okay. Victor is saying every number greater than -1 is correct. So it means -1 itself is not correct. Good. How about, now let me confuse you properly. How about About a half. About a half. Is a half correct? A half is correct. Someone should put for me in the calculator, how is a half written in decimals? Put in the calculator and tell me how do we write a half? 0.5. I has got it. This is the same as 0.5. So now my question is 0.5 correct? Okay. So a half is correct. How about is it negative 0.5? Let me now confuse. How about negative 0.5? How about negative 0.5? Is that correct? Okay. And then about negative. Okay, let me close the chat for now. How about negative 0.9? Let me put it here. How about negative 0.9? Is this a correct answer? Yes, Victor.
Yes, teacher, it is correct.
It is correct. Okay. Victor says it's correct. Let me hear from Kwagala Daniela.
It's correct.
Why?
It's correct.
Why is it correct, Daniela?
Because they say that that
They are saying that X is greater than. Daniela has disappeared. Okay, Daniela has gone. Let me hear from Rahim.
0.9 is greater than negative 1. Negative 0.9 is greater than negative 1.
Okay, good. I wanted to remind you of something. There's a way everyone was saying that girl is right. But let me put for you here. I want to draw for you the number line here. I am assuming you're able to see that number line. Yeah, so my number line is there. And putting a 0 here. I'm putting 1 here. I'm putting 2 here. And this is 3. So this is 1, 2. These are negatives according to what she has drawn. Now, when I say that, I'm just repeating what she has done. If I do that, have I included negative 0.9? When I do that, have I included negative 0.9? Let's write in the chat. No. Ayo says no. Any other person? No. Rahim, no. Victor, no. Okay, I want to hear from Nicole herself. Where is Nicole here? Nicole is still here. Okay, Nicole, let's use your work again. Don't you think you've left some numbers out?
Yes.
Which numbers are those?
Yes?
Which numbers have you left?
Negative 0.1 to negative 0.9.
So you realize in mathematics, thank you, Nicole. You realize in mathematics, this girl would have left out so many numbers. Let me see in the chat how many numbers. Which number do you think she has left out when she writes like that? Mine, I feel she has left out 0.9. Which number do you think she has left out when she says the answer is supposed to start from 0? I want to see the numbers you think she has left out. She has left out several numbers. Actually, she has left out almost 1 million of numbers. Negative 0.9. 9 is not correct. She has not left out 9. She has said all the other positives. So 9 has been included. Which other number do you think she has left out? Yeah, Nicole herself says 0.9 to 0.1. Yeah, still, Nicole, when you write like that, you've still left out so many numbers. When you write like that. Justin says negative 0.7, correct. Eddie says negative 0.8, correct. Even negative 0.6 has been left out. Anna, she has included 0.9. You see 0.9 is here. 0.9 is somewhere here. She has included. Even the person using anonymous, 0.6 she has included here. So she has only left those negative 0 point something. And like Ayo has said 0.99, 0.6, 0.5 from Daniela. Yeah, all that is correct. So she has left out those very many numbers. So in mathematics, this is how we represent those very many numbers. Okay, maybe let me hear some suggestions. If I want to include those numbers, what do I do? Do I have to draw this and leave it here such that I start from there to include those numbers? Because it's only 0, it's only -1 that I'm fearing. This is not part, which is correct, like she had feared it. But all the numbers here, when I put in the middle here, would I have answered it correct by show of hands? Or any suggestions? What do you think I should do here? There is this person called Ayo. Ayo, talk to us. What do you think I should do? Ayo, talk to us if Ayo is not ready. Eddie, you seem to have got this right. Eddie, talk to us. No one has got this right. Okay, let me hear from Nicole herself. What do you think I should do?
Teacher, do where?
How do I have to put this arrow for it to be correct?
I'm not sure.
Sure. Okay. Oh, sorry, don't open the microphone again. Okay, now let me show you this. This is what you're supposed to do. When you realize that they are saying a number is greater than -1, this one means all the numbers that are greater than -1 are correct, apart from -1 itself. So what you do, you start by telling the examiner that, you know what, this -1 is not. Then you draw your line from this very -1 up to here. So in other words, you're supposed to draw your arrow with an open small box on one like this, going this side. This one means all values that are greater than -1 are included apart from -1 itself. Something like that. I don't know if you've seen that. By show of hands, if you've understood that. This is something we saw in primary, but it's possible that you had forgotten. It's by show of hands if you've seen that. Okay, people here can't put hands up. Okay, I'll assume you've seen. Who is saying we've not seen that? I've seen a thumbs down. Thumbs down. How I wish I can see that name and you tell us where the problem is. The person who put thumbs down, unfortunately, I didn't see your name here. How I wish you could put it again so that we can see you. Thumbs up for those who have seen, thumbs down for those who have not seen it. Thumbs up from yes, Kakoza. Yes, thumbs down from Justin. Okay, Justin, tell me where the problem is.
Why are we putting that small circle? Why don't we put a line?
Why are we not putting a line? Oh, okay. Yeah, you're right. Why don't we put a line? Any person who can help Justin see why we can't put a line here? Any person who can help him? Because you put the thumbs up, try to see. Try to talk and we see if it can help Justin. Why are we not putting a line? Instead, we are putting a small circle.
The circle is a starting point.
No.
The circle is a starting point.
Sorry about that. My internet went off. And yeah, I've lost my screen that I was using here. But I'm going to say something about what Justin had said. Then we'll continue. Why are we not using the line? Instead, we are using the circle. For that, let me put this quickly. That then we have a 0 here, a -1 here, 1 we have a 2 here. When we put a line like this, then we push this side, it will mean even -1 has been included, which is wrong. So in the mathematics, the only way you can represent this number line such that people know that you've not included -1 is by starting from -1, but you give it an empty circle for people to know that this -1 is not part of your answer. So any value that is below -1, sorry, that is above -1 becomes correct, including -0.9. 0.9, which is just here. There are so many numbers here. -0.9 is here. There are so many numbers, so many of them that are in between here. So to show that you're including those small numbers is you put an empty circle like that. That is exactly what I was talking about. So to represent this on a number line, this is what we are going to do. So draw that in your books, a number line. And the number line must have these two parts. It should point both in front and behind. So put that in your books. Unless if there is any other question, ask it. If there is no question, we proceed to the next exam. Put your hand up if there is any doubts, if there is any queries, if there is any supplement, or else we proceed. Is everyone agreeing with that? A thumbs up or a thumbs down if you're not agreeing with that? Thumbs up. Any other person with a thumbs up? Two people with a thumbs up. Thumbs up, two people. Yeah, there is a question from KK. KK, ask your question. There is a question. KK, your hand is up or you wanted to put a thumbs up? Okay, KK must have wanted to put a thumbs up, but unfortunately rose the hand. Unless if you have a question, ask, or else we proceed. Okay, the next question is here. The next question is X is less than 4. X is less than 4. Who can do for us that? Who can do for us that? X is less than 4. And maybe before you do, I'm going to draw for you a number line here. Then you're going to do for us. Yes, Nicole, you can do for us that. I'm helping you put the numbers. Nicole, you can start from there. Use a different color. Use maybe red, such that it doesn't look like mine. Show us how to put X is less than 4. Right, I think that is correct. Thank you, Nicole. And maybe you can explain, tell us why you've used an empty circle. Oh, you forgot to put this. Nicole is not able maybe to talk to us, but this is correct. Any person who agrees with her? Any person who agrees with what she has done? If you agree with what Nicole has done, thumbs up. Okay, 2 people agree with what she has done. And this is correct. This is very correct. Funny. This is correct from Nicole. And what makes it correct is because her answer does not include 4, but it says any number that is below 4 is part of this. Those who are writing, this is how. And yeah, it remains an empty box. It remains an empty box. And let me go to the next one. Now, if it is greater than or equal to 3, it means the first number is 3. First number is 3, 4, 5, and so on, like that. Now, for such cases, we use a closed box. Use a closed box. So this is what I'm going to do. For such cases, it has to be a closed box. Such cases has to So for such cases, they are saying x is greater than or equal to 3. This is how we write that. If it's greater or equal to 3. I will assume everyone has seen how that is written. Why do we use an empty box? Why do we use an open box? An empty box means that number is not included. Closed box means that number. Assume we've seen that. Okay. Thumbs up, thumbs down. Thumbs up. 4 thumbs up. Jordan here says up. Then Shan also confirms. So man. Can I sample someone? Why do you think this is correct? By show of hands, if you know this is correct, you can maybe help the class understand it. Why do you think this is correct? Yes, Rahim.
Because in this case, 3 is among the numbers. So like if you shade the thing, it includes 3. If you shade the box.
Okay. Yeah, Riham has attempted to explain it for whoever may have not got this right. So now me display the correct one for those who are down. Correct one is supposed to be like that. Negative, 3 up to infinity is part of this. And x is greater or equal to 3 is represented like that. I'm assuming we are together at that point. So if it's less than -2, I think that is obvious. This is how we represent it using a full circle. And I want to show you something slightly different. The first one is -2 is less or equal to x less than 3. How do you represent that number line? First of all, let me sample by show of your answers in the chat. For this one, this first one, maybe let me cover the second one such that doesn't over confuse. Let me first close this. Let me first close that. If the question says the value of x is between -2, sorry, I even used between. -2 is less or equal to x, less or equal to -2 is less or equal to x, less or or less than 3, like that. What are the possible answers? I want to see in the chat. What are the possible answers to that rule? That equation is the, of course, the obvious one is that -2 is part of it. Which other number? Put it in the chat. Which other number is part of that equation or part of that inequality? -2 is part. -1 is part. Which other number? -4. -4 is not part. 2 is part, correct? 1 is part, correct? Yeah, Ayo has summarized for us everything we need here. Ayo has said -2, -1, 0, 1, and 2. I think Ayo has summarized it. Angel has summarized it as well. Rodney has 0. 0 is correct. 0 is part. -3 from KK. -3. This one is not. That one is not part. Okay, I think we can leave it at that point. Yeah, so these values include, like those people have said, they include -2, -2, -1, 0, 1, and 2. So the other ones are not part. So what we do when we want to represent this on a number line, who can try to show this to us in the number line? If for you are sure you've seen it well, represent for us this on the number line. I'm going to draw a number line here for you, and I will open the annotation to allow you to draw it on the screen. Rahim, I'm going to give you a chance. Okay, Rahim can proceed and show us how to put that on a number line.
That's it.
Sorry?
That's it.
Yeah, I thought you were still adding. I'm going to open people's microphones such that it is easier for you to open. I pray you don't misuse that chance. Okay, Rahim has told us she has finished. I want to say she has done her best, of course, but there is something slightly missing. Who has seen it? Who has seen what is missing? Open your microphone and say if there is anything missing. Power. There is something missing on our. If you've seen it, put your hand. There are some values here, like 2, 2.5. 2.5 has been left out, our 2.8 has been left out, and so on. Are they part of this? And if you've seen that, how would you best represent this such that you get this right? Raham, yourself, you want to correct it yourself? Rahim, you can proceed.
So like I had to put a ball.
Yeah, go ahead and use the balls.
So like okay, cha.
Let me clean this for you. Let me clean. Okay, start again. Put up, put up. Okay, now this is very correct, apart from this one, where I want to put for high ball. Maybe she tried to put a ball and it didn't bring it out. This one means -2 is part, and this is grade. And in mathematics, this is read as x is between -2 and 3. I opened your microphones, but I think I won't manage the sounds. That is the sound that is coming from your backgrounds. So this is how best we can represent this. It is just a continuation of what we had seen the other side. So give it a thumbs up if you've understood it, or a thumbs down if I have to say something more about it. Thumbs up, Rahim. Who else? Oh, thumbs up, many people. 2 people, thumbs up. Okay, Jordan, thumbs up as well. Okay, I've seen this. It's well. We can proceed. So this is how you were supposed to have done it, and I want to display the correct number line. The correct number line is like that, and -2 is it's part of it. -2 is part, then -2 is part, but 3 is not part. My number line has some issues. Don't know if you've seen those issues. Let me correct them. This is not negative. This is 1. Then this is also not -2. Yeah, like that. Yeah, the next task is there. And this one, I don't want to waste a lot of time. The 2 is not part, and the 6 is not part. And this is how we show it on the number line. 2 is not part, and 6 is not part. So any values in between 2 any values in between 2 and 6 are correct. The thumbs up if part B is okay. That second one. Want us to go to something else? If that is okay, thumbs up. Okay. Some 3 people have thumbs up. Then the rest I really don't know. Yeah, in the previous exercise, I left for you this work. I wanted you to put it on the number line, and the work is there. Just in case there is any question, let me know. Is there anything here that you see it's not clear? I would help demonstrate it on a number line, and you see how they do it. And if all is okay, then we can proceed. Put your hand up if I should demonstrate something here. All of them seem to be not very, very hard. All that was a recap of the previous lesson. We attempted to talk about that in the previous lesson. So in today's lesson, take a screenshot of that exercise and try them out in your free time. Inbox me if in case I must go through your work. I'll leave my number in the chat. Just in case you've tried to do them and you feel I should look at your work, inbox me such that I can try to go through it and see. But I'm sure from A up to G, all that is possible. Okay, in today's lesson, I want us to talk about what we call the solution set of an inequality. If you've been given a task like x is greater than 3, what is the solution set to that? And the solution set, there is an introduction there, but what I can talk about the solution set is that you start by telling us that x is equal to, then you put this in bracket. A solution set is supposed to be a set of values that satisfy that equation. For example, a solution set to this is x is greater than 3, then the solution set will start with 4, 5, 6, and so on. That becomes the solution set. We don't use the values below 4, like 0, like 3, like 3.1. We don't use them here because we so much concentrate on counting numbers. But you very well know that x is greater than 3. Even 3.1 is part of the solution set. But because the standard says we must use counting numbers, so the decimals are skipped. But when you're putting on a number line, that's why you always include those decimals by putting an open circle. So a solution set to that is written like that. And it's very important for you to know how to write a solution set. And I'll start by displaying the correct solution set to this. The solution set for the inequality x is greater than 3 must have values of x greater than 3, i.e. 4, 5, 6, 7, and so on. That one is going to be called the solution set to that inequality. If you've been given an inequality, a solution set will mean the values that always satisfy that condition. So in the next example, I want us to see the solution set to x is greater than or equal to 3. Who can give us that solution set? X will be equal to, give us that solution set. Who can give us that solution set by show of hands? No person has put the hand up. Okay, Nicole.
X is equal to 3, 4, 5, 6, and so on.
3, 4, and so on. This one is according to Nicole. Any other person who could be having either the same or a different idea? Let me open your set here. If it's the same, we shall know. If it's not, we will see what to do. Any other person? Any other person? Jordan?
X is equal to 3. 2, 1, 0, and others.
Yeah, and others. This is Jordan. Yeah, thank you, Jordan. The next person, you might agree with Jordan, or you might agree with Nicole, or you have the complete different answer. Put your hand up and share with us. Put your hand up and share with us. Yes, Grace.
Solution set for x is 3, 4, 5, 6, and so on.
6, and so on. This is Grace. Grace has that. Yeah, Jordan seems to be the only person with that, unless we have other people who believe what Jordan has given us is what they have. By show of hands. Even Jordan, your hand has gone down. Yes, Daniela? Daniela, Jordan, you're not alone. We have even Daniela. That is. Daniela, are you part of Jordan's team? Kwagala Daniela? She can't open the microphone. Okay. But Jordan, let me give you a chance to say something about your work. People seem to have refused it. But maybe before you say something, let me see if there are some people who agree with what Nicole has and Grace. Do we have anyone who agrees with what Nicole has and Grace by show of hands? Yeah, 2 people, thumbs up, including Kakoza. Kakoza, why do you think that girl has passed it? The 2 girls.
The thing, it started from great or less, great or equal than, starting from 3 and above.
So you don't agree with Jordan's response?
Yes.
Why?
It's going less than instead of greater than.
Yes, so Jordan, I think you've seen your mistake. You're instead using the arrow in the other way around. Yeah, thank you, Isaac, for that. So this is the correct way of writing it. And I will put that solution set just on the screen. So the solution set is already there. And with 3 inclusive. So 3 has to be part of that, like Nicole and Grace attempted to see. Let's post the answers, the solution set to this task in the chat. I've just opened the chat. I want to see who could have got this right. What do you think is the solution set to this? Yeah, I think the response shows that almost everyone is getting it right. And then for KK, someone is using KK is saying, can we increase on the brightness? I've not understood that. Yes, my screen is not very clear, so it may not be about the brightness. Just make sure you're able to see, like your friends have seen. I've liked work from the first person to give us was Isaac. Thumbs up for you. And Angel gave us the correct one. Angel, I'm not just liking the brackets you're using, but of course the concept is correct. Ayo gave us the correct thing. I will post Ayo's work here, first person. Of course, Ayo gets it right because Kakoza did not put X is equal to. So I will post Ayo's work here. Ayo gave us that correct one. Then this is Ayo. Kakoza was the first to get, though he did not include that X is equals. Then, yeah, including Nicole's work is very good. Nicole seems to be at the top of the game. What is making Nicole's work good? Yeah, Nicole is correct. Then, of course, all of you are correct, but I did not put clearly the standard of writing this answer. So let's see what I have here. What is here is the solution set is -1, 0, 1, 2, like that, like Nicole and Ayo have stated it, and the rest of the people who tried to write the 4 numbers. So now we'll proceed. And the next one is here. This one, of course, Unlike the previous one, this one, even -2 is inclusive. So -2 becomes part of this, and that's why you're seeing is less or equal to x, less or equal to, and -2 is less than or equal to x, less than 3. And these are the values. So I want to pause it at that and ask if anyone has a question. Any question before we proceed? Okay, no one seems to have any question. So we will proceed. So in the remaining small time, I am going to talk about how to solve linear inequalities. And when we talk of linear inequalities, you're going to see how it looks like. And we want to learn how to solve these linear inequalities. And in the previous curriculum, for those who have opened these question banks, this would give you 2 questions. If you've been asked to solve a linear equation, a linear inequality. If they ask you to solve it, you would walk away with 2 questions. This was a question that you would not miss. And in the new curriculum, well, you may not see the question directly, but you're not going to survive it. They're going to give you a scenario. A scenario may look like this. A scenario may look like this. You have been given a perimeter of a rectangle shown below. You've been given that the perimeter of the rectangle shown below is less than 44. Form and solve an inequality. So a rectangle, they may tell you this is a piece of land. Someone, it could be John, has a rectangular piece of land, and its perimeter or the distance around it is less than 44. And that is what John remembers. Then they ask you to help and form and solve that inequality, such that you tell us which one is the length of this and which one is the width of this land. So this particular subtopic is going to be very, very helpful. And this is how we go about it. The first step is, when solving, can we get someone to read for us this? At least I want to hear people's voices. If you've not said anything completely, at least. Now for you with no name or the name is funny, how do we now pronounce Aregi? First tell us your name, your correct name.
I'm Ira Gertrude.
Ira Gertrude, okay. Or maybe it's me who did not pronounce it well. Gertrude, yeah, you can proceed.
When solving linear inequalities, we use the same techniques as those used for solving linear equations.
And Gertrude, do you remember linear equations in first term? Actually, it must have been in algebra 1.
Yes.
Give me an example of a linear equation. They can say solve x plus...
Solve x plus 5. X plus 5 equals 10.
Equals 10. Yes, so this is what she's talking about. That when solving linear inequalities, we use the same techniques as those we used for solving linear equations. So when you're given something like this, it is the same technique you're going to use the other side. Gertrude, you can proceed.
The same number may be added or subtracted from both sides.
The same number may be added or subtracted from both sides. Can you explain for us that using your example that is here?
Let us say that the equation is x plus 5 equals 10. So when they say the same number may be added or subtracted from both sides, 5 can be subtracted by saying x plus 5 minus 5 equals 10 minus 5 because it has been subtracted from both sides.
Yes, that is correct. And why do we always subtract?
Because if you say x plus 5 plus 5, it will give you a wrong answer. So how they taught me in primary, they said if the sign it's a plus sign, you have to subtract. Then if it is a minus sign, you're supposed to add.
Do you know why we add and subtract? Okay.
Not exactly.
You'll get back. Let me first hear from Kayla. Let me see if she knows or if he knows why we add or why we subtract. Then we'll come back to tell us more. Yes, you can proceed. Why do we subtract?
So if you say x plus 5 equals 10, and then you say x plus 5 plus 5, that means you're adding another 10. So it's basically x plus 10 equals 10. And we want to remove that number in between. So we subtract so that we can get no number. And yeah, that's what I know.
Just wait. When I add, you mean when I add I have failed? When I say x plus 5 plus 5 is equals 10, I'm adding. I've gotten annoyed and I'm adding. Have I failed when I do like that? This girl's microphone is closed. When I do like that, have I failed?
Yes.
Are you sure? Let me see. X,
Yeah.
it will be now plus 10 is equals 15. This one is not wrong because I added 5 on both sides. Maybe let me use an example of the weighing scale here. I'm forgetting how they do a weighing scale. But let me assume this is a weighing scale. For those who have been to where they sell things from, here they put a stone and the sugar is this side. So if the sugar that you have this side is a kilo, here I need a stone of a kilo, and it is balancing. And what if I add another stone here of a kilo? What happens this side? Whose microphone is open? Gertrude, what happens this side? I have added another stone this side. Does it remain balancing? Gertrude, your microphone is open at least. Who has seen? What happens to this side? Does the sugar this side, let's assume this is our sugar. I have added another stone over half here to make it 1 kilogram. What happens this side? Does it go up? Does it go down? Does it balance? For those who have ever seen a weighing scale, are people able to hear me? Isaac, what happens to that weighing scale?
The part of the sugar goes up.
Goes up. So it means it's not balancing. So what do I do this side to make it balance?
You add another half.
I add another half of sugar, like this. So what we do with this, I don't know how you studied it. You could have studied it differently, but what we do with this is we are assuming there is sugar this side, there is this other side, the stone. So if it is x plus 5 is equals 10 this side, Why do we always subtract? Because we want to destroy this 5 completely such that the x remains alone. So I will say, how do we destroy 5? I subtract 5 from it. I destroy it to 0. So now when I destroy it to 0, it's like saying we are removing a half from this side. This one goes up. If we remove a half from this side, it goes up, sorry, this side. So when you remove, because your intention is to destroy this a half, you have to do the same this side immediately, such that it remains the same, or else this one will go up, one of it will go up. So why do we always subtract? Because I want to destroy this 5, so I have to do the same this side to make my thing balancing. I also remove 5 such that it remains the same. I've destroyed this side and I've increased this side. But depending on the question, if it is a plus, we subtract and on both sides. Why? Because we want to destroy this and we remain with only the unknown. Some books, of course, when they explain this, they say this number fears the equal sign. When it crosses this side, it becomes a negative. How do you now say when it fears this, it becomes? So what is very true here is that we always subtract because we want to destroy this 5 here. What if it was -5 is equals 10? Here, how do we destroy -5? On it, we add a 5, which is positive. To destroy it, so you add a +5, and this one would have been destroyed to 0. So if you're adding a 5 this side, then obviously you must add a 5 this side. Not that when it crosses the equal sign, it becomes a positive, no. Because we want to kill it, we want to destroy it. But when you destroy it on only one side, the other side becomes smaller or it becomes bigger. That's why what we do this side, we do it this side because we are respecting this equal sign, which they are saying a linear equation. A linear equation is always having this equal sign to give you the standard. What this side is must be the same as what is this side. So when you are changing anything on one of the sides, make sure you also do the same on the other side. Yeah, so I didn't like it when Gertrude was saying you subtract, and she was saying they told me that this is exactly what happens. We subtract because we always want to destroy this other value such that we remain with the unknown. So Gertrude, you're going to come back here and take us through the last part. And you had reached, you had said if x plus 5 is equals 10, then when they say add on both sides or subtract on both sides, because this is a plus, we will add and immediately subtract 5 from this. And the reason is because we want to destroy that 5. So this becomes 10, take away 5, like that. So Gertrude, if you're still here, take us through the last part. Okay.
It's coming down again.
Okay,
X
proceed.
since
Sorry.
Since it is +5 and -5, it results into a 0 and only x will remain, and the answer will be x equals to 5.
Yes, so this will become this will be destroyed, or like she said, it will be resolved to 0, and then the answer becomes x is equal to 5. This is how we solve linear equations. Okay, that's good. Gertrude, last point is this. Help us understand that.
To understand which point?
The third point, you had talked about the 2 points. There is that third one there.
Oh, okay.
Okay. Multiplying or dividing both sides or dividing both sides by the same positive number leaves the inequality unaltered.
Do you have something to say about that? Maybe using an example, or we give someone else to explain that.
Yeah, you can give us others a chance.
Okay, do we have any person who can explain bullet number 3? Your hand should go up and listen in to what you have.
What is this?
There is this girl, Grace. You're keeping quiet. Can I know if you can explain that? Grace? Okay.
Yes, sir.
Try to explain bullet number 3.
Okay. Multiplying or dividing both sides by a positive number leaves the inequality unaltered. So I don't know how to explain it.
You don't know how to explain that. Okay. Yeah. Let me try to do someone example here. For example, if you have 2x is less than maybe 10, for example, like this. 2x is less than 10. When you divide by 2 this side, your answer becomes x is less than 5. This one means you have left the inequality symbol unaltered. But if you attempt to divide through by a negative, for example, if I say negative 3 is greater than 15, like this, and I'm dividing through by negative 3. This one, this becomes x. This equal sign is supposed to be altered because I'm dividing through this negative number. That is what the meaning of that is. So this becomes less than 5, like that. The equal signs change. I mean, the inequality symbol change when you divide through by a negative number, or when you divide through by the same positive number, the sign remains the same. And that's why I'm leaving a note here that the last one says multiplying or dividing both sides of an inequality by the same negative number reverses the direction of the inequality symbol. And I want you to try this out and see how it will look like. But for now, we may not have enough time to have as many examples as possible for you to understand why it changes. But maybe what you can take from me is that when you divide with a negative number, it's supposed to change. And I'm going to take you through 1 or 2 examples here. First example is here. They're saying solve the following inequality and represent each solution on a number line. How do you solve that? What is the solution set to that question number 1? The solution set to that question number 1 is a bit hard, not until you solve and get what exactly is x greater than. So if for such cases, you must get the value of x, then put it on a number line and go ahead and write the solution set. Using what Gertrude told us, we solve this, or we solve this, of course, using the previous knowledge that you learned in senior 1 and in primary of adding or subtracting on both sides. Then go ahead and represent that on a number line and go ahead and give us the solution set. This is very easy, and I'm going to, of course, give chance to someone to take us through this You'll talk as I try to write for you from this side. And if you get it right, your friends will tell us. And if you get it wrong, we shall obviously get another person to take us through that. By show of hands, who is taking us through this? Yes, Jordan.
X plus 3. X plus 3 minus 3 minus 3 equals 5 minus 3
equals
sign. That's sign.
Sorry? Is it equals?
No, that's
what
sign.
What is that sign?
Is greater than 5 minus 3.
Okay,
yes.
greater
than 5 minus 3.
Okay, why have you said minus 3?
Pardon?
Why have you said minus 3, not plus?
Because x plus when you are taking this number to the 5, like it changes from a positive to a negative because the other side it's smaller. Like the 5 side, it's small. This side is greater than. So it must change and bring a negative.
Yeah, you
so
tried,
that it
but
can go to the other side.
Okay, but it's not the main reason why it is negative 3. Any person who seems to have known why we always subtract negative 3? Any person? Of course, Jordan, you have to prepare to finish this, but I want to see if any other person here can help.
Okay, I think the reason why we subtract 3 is because that the greater in other way acts also like an equal sign, and if we want to transfer it in the other side, because it is positive, it changes to negative. That's why we have to subtract. I think that's my opinion.
Okay, but maybe before David goes, why are we even struggling to take the 3 the other side? And it was comfortable here, and we are taking it the other side. And for you, you're saying
we are struggling to take it in order to make X as the subject.
Or to make X the subject, yes, and that is where the reason is. Let me see if Rahim can summarize this for us. Rahim, why do we subtract the 3?
If 3 on each side, the number won't change, and like you wouldn't get X.
I beg your pardon, you're breaking. Beg your pardon, you're breaking.
If we were to add 3 on both sides, the number won't change, it will remain the same, and you wouldn't have found the value of X.
Yeah, Rehab seems to have seen it. We are struggling to take the 3 the other side because we want X to remain alone. David, do you want to add something?
Not real, but I think that is the aspect. Just because we want to make X as the subject, that's why we're struggling to take it the other side.
Yes, we struggle to take it the other side, and that's why we are subtracting. And why we subtract is because we want this to give us plus 0. You see, X plus 0. Then we take it the other side, and that's why we see that. Yes, Jordan, you can proceed.
X plus 0 is equal to, no, X plus 0 is greater than 2.
Correct, yes.
X is greater than 2.
X is greater than 2, yes. That becomes your solution. And can you show this on a number line? Do you know how to show that on a number line, or we get someone else? Jordan, we give it to someone else, so you're going to manage. Jordan, take us through this on a number line. Okay, who can represent for us this on a number line? Thank you, Jordan. Of course, this is correct. This is correct. But can someone put up the hand and show us on the number line how to go about this? Who is taking us through that? Jordan, at least you've already tried. Let's give chance to Grace. Grace, are you ready?
Yes, sir.
Okay, pick the pen and show this. And Grace, don't deceive us because you seem to have started to deceive. X is greater than 2. X is greater than 2.
So that's what I think.
X is greater than 2 starts from where?
From 0.
From 0.
Yeah.
Okay, thank you, Grace. But it doesn't start from 0. Let me hear from this Kiara.
From 2.
How do you pronounce that name? Okay, Karen, you can draw for us this. Great, thank you. I'm cleaning your work here, and we see what Karen has. Karen, do you want to do the work? You show us on the number line. Karen. So completely. Okay. Maybe technology is not allowing. Someone has drawn. Karen. Now, Karen, what I don't know, is that an empty circle or a complete circle? Karen, open your microphone and talk to us.
It's a colored circle.
What? A colored circle. But the answer was not greater than, remember, it was not having equal to. So if you put colored circle, then you've deceived us a little bit, Karen. Jordan is giving it a try. Yeah, Karen finally has come back with it. I think Jordan first give Karen a chance to finish. Then we see if she's not right, we'll give some other person a chance. Yeah, Karen, proceed. Let me clean for you what people have written here. Yes. And that is exactly what you have to do. Why? Because 2, much as we are starting from 2, but 2 is not part. And this is correct. Karen must have really understood what to do. Karen really understood what to do, and that is very good from her. She has clearly showed that this is how to put this on the number line. Let's go to the chart and put the solution set. The chart is open. Put the solution set in the chart. What is the solution set to this? What is the solution set to that? Of course, our inequality is here. X is greater than 2. Write the answers of the solution set in the chart. And the solution set is written, you start with equal signs. Yeah, Karen still gets it first. Karen's answer is here. This is not to only Karen, but to all of us. Yeah, Karen has it. This is Karen. The next person I saw was Rahim. Rahim has given us something like this, and he has not completed that bracket. So Rahim, your work is demanding, you need something. Someone with KK, someone who is using KK has given us something like this, using an account KK. Still, it is lacking something. Kakoza, this time round, gets it correct. It's called Kakoza. Let me use Isaac, it's shorter. Then Ramona gives us this. Ramona gives us that, which is correct as well. Then, of course, I can't list everyone's work. Jordan, this is good, though the brackets you've used, I really don't like these ones. They don't represent a set, they represent coordinates. David gets it right also. Sometimes sets are written like that. David gets it right. Gertrude lists them just like this. I don't know why Gertrude is listing. Just listing, yeah. And Gertrude claims it ends on 9. Others doesn't care. You're supposed to tell us that it continues. Appeal, Leah Morin has appeared for the first time, and she has got it right, apart from the wrong brackets. So then KK finally has put the brackets, but still KK, your work is missing. X is equal to. And all these are the answers that I have seen in the chat. I will put all of them in the chat and we proceed. So I would say, I would give the following people marks. And this is correct. This is correct. Apart from completing this bracket. KK, your work doesn't have these brackets. Isaac, this is correct. Ramona, this is correct, but the brackets you're using have issues. Even Jordan, this is correct, apart from the brackets. David, this is correct. The brackets, however, show as if you're doing matrices. That's why you have to avoid those brackets. Gertrude, next time put brackets. And when you reach 9, put ... such that we know that other numbers are following. Appeal, this is correct apart from the bracket. KK, this is correct, but put X is equal to at the beginning here. So that is probably our teachers told us not to put the brackets. Okay, the teachers didn't tell you to put brackets, huh? What do we do to this solution set? Normally, solution sets are supposed to have brackets. And if the teachers have told you not to put brackets, maybe we'll get this at the later end. When you reach senior 4, they will harmonize whether you should put brackets or not. For now, do what the teachers told you. If it's to put. If not putting, take it the way you know. But when you reach senior 4, they will harmonize such that you get to know what is the real right thing. Yeah, so the correct answer was x is greater than 2, and this is how the number line was supposed to look like, and Karen did it for us. Take a screenshot, of course, for this, such that we live with that. The second question that I want us to try is this. I want us to see, if you're given such a question, a volunteer should read for us this. Volunteer should read for us that. Yes, David?
Okay, thank you. Thank you, sir. The question says that the area of the rectangle shown must be less than 50, but greater than or equal to 10. Form and solve an inequality. That's the question.
Repeat the question once again.
The question says that the area of the rectangle shown must be less than 50, but greater or equal to 10. Form and show an inequality.
Okay,
the area of the
yeah, that is just one of them. And I want you to read this, because that one is slightly above what you've learned. Maybe try that and we see. That one could be lighter.
Okay. Given that the perimeter of the rectangle shown below is less than 44, form and solve an inequality. And the perimeter is, the length is x plus 8, and then the width is x.
Okay, any suggestions who can help us form for us that inequality? The perimeter of this must be less than 44. Any ideas? Let's brainstorm. Yes, but these hands are just the same. Rahim?
X plus x plus x plus 8 plus x plus 8 is equal to 44.
Is equals, are you sure? 44?
No, is less than.
Is less than?
44.
Is less than 44. Is there anyone who agrees with what he has said? Your hand should go up, or you say thumbs up. Yeah, Reham, the hand, of course, is permanent up there because you agree with what you said. Any person who agrees with what this inequality is, the perimeter of this is less than 44. Anyone agreeing with that? Okay, thumbs up. Okay, anyone disagreeing? Amos, do you agree or disagree? Amos? Amos, do you agree or disagree? Maybe Amos is not ready. Angel, you only gave us the opening prayer and you've not said any other thing. Angel, do you agree or disagree?
I agree.
You agree, correct? Let me see who else is here. Imat, hey, don't know whether this is immaculate or who. Do you agree or disagree? Imat or immaculate, or which name is this? Do you agree or disagree? Gertrude, that emoji you shared looks funny. I don't know, what does that mean? Are you annoyed? Yeah, confused, huh? Gertrude, the emoji says you're confused. What is confusing you? Or you shared the emoji accidentally when you didn't know what it means?
My actually, like, my network isn't stable, so I've been going off when you're. No, my network, it's not that good, and like when you're explaining, like the network goes off and I don't get what you're saying.
It's well. Unfortunately, we've already passed. You just hold on to here where we are. Okay, Apio seems to have given us an alternative way of writing this in the chat, and it's correct. And even Karen has given us an alternative way of writing this, and it's correct. So, Karen, your alternative way, is it the same as what David has told us, or we take yours and leave his? Karen?
I think both are correct.
Both are correct. Okay, let's go with his. David, come back and continue with your work. David, David has gone off, huh? Okay. Who can continue with David's work and we get the answer? Your hand should go up. Put up your hand and continue with David's work, or you give us an alternative. Leah, can you manage to continue where David had stopped?
Yeah.
It's okay. Proceed and you.
2x 2x plus 8.
Yes.
Less than 44. Minus 8.
You're going off. You're going off. First study it again.
What?
Let me hear from Jordan.
So, me, I think we should take the first way. We get 4x plus 16 greater than 4x plus 16 lesser than 44 minus 16.
Again, minus is coming from where?
Minus 16. No. Yeah. So we go again, 4x plus 16 minus 16 less than 44 minus 16. Yeah.
Okay.
So that it's 4x plus 0 less than 28. 28. So it's 4x less than 28. We divide 4 on both sides.
Give us.
Here it's x. Remaining is x. X is less than 7.
Less than 7.
Yes.
Like that. Yeah, so you would have tried to
That's
write
the
this.
inequality.
Okay, thank you, Jordan. I think that is good. he has formed for us the inequality and gone ahead and solved it. Now, what I want to end with is can we take a screenshot of this, because I'm about to close that screen and it will go. Yeah, someone is saying I got the same. Yeah, good. If you got the same answers. I'm putting off this, and I want to just do the last part of today's work. The last part of today's work is, if you're given a task that has both signs like this, how do you go about it? If it has both signs like this. So this is what I will demonstrate here. They have given you 3 is less or equal to x plus 2 less or equal to 8, like this. So this will be 3 less or equal to x plus 2 less or equal to 8. I want to destroy this 2, so I will take away 2 from this. I will take away 2 on both sides, like this. What I wanted to explain here, if you're destroying the 2, subtract it on both sides, such that it looks like this. It now becomes 3 minus 2 less than, okay, maybe this may not help me. This may not help me. Okay. So it becomes 3 minus 2 less than x less or equal to 8 minus 2. Of course, there is a minus. I wanted to demonstrate something here. This will become x plus 2 minus 2 is less or equal to 8 minus 2. This step is very important. It shows you that when you want to destroy x, if the inequality has both signs, if you want to destroy x, then remove it on both sides. Remove it this side, remove it that side as well. Something like that. Yeah, so that is what I wanted to demonstrate, because you might come across a scenario that wants you to solve it that way. So this becomes 1 is less than x less than or equal to 6. And this becomes our answer. Yes, Jordan?
Yeah, can you show us the other question of whereby it had 50 of a rectangle?
Okay, I will show you. And it's the one we are going to end with. Okay, so basically that is what I want to show you. And for such questions, they are solved this way. Take away the 2 on both sides and your answer looks like that. And if you can only understand that, it's very, very good to go. So I want to end with what Jordan has requested. Oh, Grace?
So I wanted to ask, like, could you give us an example of a scenario which is set like that?
Which is set like that. It's what I'm going to display.
Okay.
Okay, the scenario, I may not have a very good scenario because I didn't give this a lot of time, but they can tell you of a piece of land that must be less than 50, but not greater than or equal to 10, like that. There is one scenario there for you, Grace. And they are talking of the area of a rectangle. They may say a piece of farm. Maybe someone is planting sugarcane or what on a rectangular piece of land, and it shouldn't be less than 50, but greater than or equal to 10. Form and solve that inequality, and they've given you a sample of that rectangle there, and you're supposed to write and put it so well. So this one, who can try to write this? But I feel you're so tired, you may not overthink, but this is how you're supposed to write it. The area of this rectangle should be less than, less than 50, and it should be not greater than or equal to 10. So it should be still less than or equal to 10, something like this. It is, of course, less than, this area must be less than that, but of course not more than 10 again, according to, but greater than or equal to 10. I think this is supposed to be greater than or equal to 10. The area of the rectangle must be less than or equal to 50, must be less than 50, but greater than, yes, can be written like that. I don't know whether that tries to solve your problem, Grace. Let me hear Grace and who?
Yes, sir.
Something like that. Of course, the scenarios always vary, but the mathematics behind it has to be written like that. Then our area is known. Our area is length times width. So I'm going to get my 5 and multiply it by x plus 4. Should be greater or equal to 10. So this becomes 50 less than 5x plus 20. Yeah, something like that. You can go always follow those steps and you get there. So I want to end this by leaving for you some exercise. There is a lot, of course. There is a lot that we needed to do, but I believe the knowledge you have can kickstart you to do all these numbers. Solve the following inequalities, illustrating your solutions on a number line. You can get time and do this for those who can get some time after this lesson. And I request that we both get time and try this out. They're not very hard numbers. They will help you understand what we've been going through. I want to thank you all for attending this. And I want to wish you journey masses as you go back to your schools. Go and represent us so well. We have been the Holistic E-Learning Platform for 2 weeks here, and when you go back to your schools, share with your friends. I know of a senior one girl, that girl I'm forgetting her name. She invited the whole of her stream mates, and they're attending the senior one classes. She gave us all the numbers. We added all the numbers in the WhatsApp group, and for them, almost the whole stream was following this. You can do the same in the school where you're going. Pick at least 1 or 2 friends, come here and we interact. Always, Holistic E-Learning Platform lessons give you a feel of what the next lessons will look like when you go back to your classes. And our intention here is to support you such that you can excel wherever you have gone. And excelling means in the chapters that we've attempted to talk about, when the teachers introduce them the other side, they give you an activity of integration, you get a 3 and only a 3. Thank you once again. And I want to get a closing prayer from anyone who is ready, or any question, if there is any question before we leave here. Put your hand up and give us the closing prayer. Kakoza Isaac, bring back for me the host rights such that we can end this meeting. Kakoza, good. Can we get a closing prayer from anyone of you who is ready? Take away this blessing by giving us the closing prayer, sorry. Here people don't want to pray. Can I pick at random? Yes, Grace, you can give us the closing prayer.
Heavenly Father, we thank you for this day. We thank you for the gift of life. We thank you for the lesson, Heavenly Father. As we are going back to school, we pray for journey mercies. We pray for knowledge, wisdom, and understanding. In Jesus Christ's name, may He bless everybody else. In Jesus Christ's name, I pray and believe. Amen.
Amen. Thank you very much, Grace. Grace, which school is that?
Iganga SS.
Gasco. Yeah. Yeah, it's a very good school. We pray that you bring for us more people when you go back to your schools. Yeah, thank you for being
Amen.
part of this, and we meet again.